So whenever I talk about encryption, there will be of two types of encryption. What is that? So encryption, if I say, okay, two types of one encryption. One is called as symmetric encryption, and another is called as asymmetric encryption. Symmetric encryption, and asymmetric encryption. So what is the symmetric encryption and what is this asymmetric encryption, Kiran? So yesterday we have seen what we have seen. We have seen encryption technique, which is a popular encryption technique, which is called as Caesar cipher. Caesar cipher is the encryption technique that we have seen. So again, if I go back to the particular thing, because I want to specify based on that one. So again, if I learn ABCD, so I can always put H, I, J, K, L, M, N, O, P, Q, R, S, E, U, V, W, X, Y, Z. Okay. So a Caesar cipher is a technique where the alphabets, the position of the alphabet, changing by the position of the alphabets, you can always make it as a gibberish format. Okay, you can always make the actual text to a particular gibberish format. Okay, it is named after a particular person, Caesar. Okay, so he's a king or someone else. Okay, so because at that particular point in time, he was using this kind of technique for the people, right? For other people who they won't identify, right? So this is a kind of technique to maintain security. Okay, so this is called a Caesar cipher technique. So in this particular technique, as we have seen, so if you want to change the position, we can always say we have seen, right? So for example, cyber, okay, cyber is the particular text. Okay, so I want to change. So I can always have a fixed I can always change the position. So if I say that after four characters, okay, so I have to, whatever the character that is occurring, only after 4 characters I have to fix it. So then what I can do, so that means what? A starts with E. In my new representation, A will be always started with E, and accordingly B with F, like that. I, J, O, P, Q, R, S, T, U, V, W, X, Y, Z, A, B, C, D. Okay, so this is the new presentation. That means what? If I want to represent this cyber again, okay, so C for G, I have to put, okay, so this becomes G, okay, and Y, where is Y? Y becomes C, okay, and again B becomes F, and E becomes I, R becomes V, right? So this is the format. So this is the particular thing we'll be getting, where it is quite difficult for the other persons. Okay, for the attackers, it is quite difficult. Okay, so to understand. Okay, so that is the particular thing. So we can always implement this particular technique. So then what happens? So this is called as this technique, whatever we are seeing right now is a symmetric technique. That means what? Symmetric technique, whenever I use, so for example, say, okay, so this is my client, okay, and this is the server. So I am transmitting the data by using this symmetric technique. Okay, so what are the in Caesar cipher also there are various kinds of techniques. Okay, so this is one of the technique, right? So in any of the technique if you are using, okay, so it can always write you can always have your own kind of encryption as well. Okay, custom encryption also you can always have. Okay, that is the particular stuff. So you can always, if you are sending this particular thing to the server, so what does the server, once after getting right, whenever you use symmetric encryption, okay, the server can always go back. So this is what I have done right now over here. So I have fixed, after certain characters, I have fixed the particular things. Okay, so after D character again, my A becomes E, I am specifying. That means I have shifted the position 4 characters, correct or not? So 4 characters forward I have shifted. So A becomes E. That means after 4 positions, E comes. That's why I have shifted 4. So this is called as secret key. What is that? This is called as secret key. My secret key is equals to 4. Secret key or encrypted key. So I specify that So in the packets, I specify the secret key. Payload will be same. So payload is the one where we'll be having all the IP addresses. Okay, whatever the particular packets details, right? The IP addresses along with the IPv4, IPv6. Okay, so all those particular things, the sequence numbers. Okay, all those particular things is along with these particular things is called as a payload. So in this payload, we'll be having this particular thing. Okay, so we'll be specifying this particular encryption key. So whenever my server sees this encryption key, what does it do? It will be having always a possibility. That means what? I specify 4 as the particular encryption key. If I specify 4 as the encryption key, so now the particular server understands, okay, so now this is the particular thing, right? You have given. So for the particular response, whatever it has been sent, you have given this is the particular you are requesting with this one. So now I can understand that, okay, so G means what I have to do right now? I have to go 4 steps backward. Okay, so it can always revert back. In a symmetric encryption technique, it can always go back. Okay, so 4 steps I have to go backward. That means G you are specifying F, E, D, C. Correct or not? See, G you are specifying F, E, D, C. So C is the value. Okay, that's why. So I'll be putting C over here. Okay, and again C. Where is C? Here C is. Okay, so yeah, C. Okay, and again 4 steps backward. B, A, Z, Y. Okay, it will be putting Y over here. And F, here it is F. Okay, and E, D, C, B. Okay, see B it will be putting over here. And I again. Okay, 1, 2, 3, 4. Sorry. Sorry, it is available over here. Okay, 1, 2, 3, 4. E. So we'll be getting E over here. Okay. And V. Where is V? This is V. 1, 2, 3, 4. R. See what has become? Cyber. Again, cyber. So that means what? So whatever the key I specify over here by using a symmetric technique, okay, it can always revert back. Simple. See, it is very simple. It can always revert back the same number of positions. It can always revert back, and it can always get the exact text. Again, it will be encrypted. In that way, it will be encrypted. Decrypted. Okay, so in that way, it will be decrypted. Okay, so this kind of technique is called as symmetric technique. Symmetric technique. So in the symmetric encryption technique, who knows the particular key, whatever the particular encryption you make, who will be knowing? Who will be knowing?
Both sender and receiver.
Both the client and server. Only these two people. Any other? Okay, so there is no chance for the attackers for knowing the particular stuff. Okay, so that is the particular thing. Okay, so in this symmetric, it is important that the sender and the receiver also will be knowing. This receiver will be knowing. Okay, not only you, but a receiver also will be knowing. You have to make him know. Then only, right, he can always decrypt that one and he can always use. Okay, on this particular, a person who is using this particular computer, okay, if you send some information because your data has been encrypted, if he doesn't know how to decrypt that one, if his computer doesn't know how to decrypt that one, what is use of sending that one? Correct or not? Right? So that is the particular stuff. Okay. So this is called as symmetric encryption. So both the sender and the receiver will be knowing. Okay. So now whenever I say asymmetric encryption, okay, asymmetric encryption. So if I say the same thing only, if I take the same thing, so asymmetric encryption is the one. So what is the logic we are using over here? We are moving forward 4 spaces, right? We are moving forward 4 characters, okay, and then we have provided the particular key over here. So if you do like this over here also in this encryption key, if you specify like this, but what in asymmetric encryption, what we'll be doing? We won't specify this thing to the particular receiver, okay? We won't specify to the particular server. This encryption key value we won't be specifying. Then how it will be knowing, Kiran? Okay. So how it will be knowing? We will be converting this particular encryption key into 2 things. Okay. So whatever this asymmetric encryption is there, what we'll be doing? We'll be converting into 2 things. One thing is that it's a private key. What is that? It's a private key. Another thing is that it's a public key. Okay, public key. So what does it doing? It will be doing. So it will be whatever the encryption that you are thinking about. Okay, so it will making the encryption. In other words, whatever the logic you are making, you will be making two logics. Okay, so that's why, right, in asymmetric encryption is more secured. Okay, so that means what? Why in asymmetric encryption this logic is being preferred like this? Two kinds of logics, because one key, the private key, will be maintained by the particular client itself. The key will be maintained by the client itself. It won't be revealing even to the particular server also. Okay, even to the server also it won't be revealing. Then how the server will be identifying? It will be sending a public key to the server. Okay, it will be giving a public key. So why like that, Kiran? Because for security purpose, if this public key has been compromised, okay. So then what is the fate again? What is then again? Everything will be it will be easily identified, all your data. So then what it is compromised, then it can always use this particular logic as well. Okay, so that is the particular stuff. So how it will be doing? See, for example, what we have thought, we have taken the particular thing, we have shifted 4 characters forward, right? So this thing is the particular private key, if we suppose. So my encryption key is 4. Okay, this is my private key. So for my public key, what I'll be doing, so the logic, okay, how I can implement. So and again, this asymmetric encryption, right, it cannot be reverted back. That means what? For the client, if I specify 4, he cannot come back, only unidirectional. He can always go forward. If the server has to read, the server has to read the data forward only. If the data has been completed over here, again it has to come backward, and again from the beginning it has to read. Okay, so there is no chance of, that's why it is more secure. It is not bidirectional, it is only unidirectional. Always do remember, symmetric encryption is bidirectional. Asymmetric encryption is not bidirectional, it is unidirectional. Okay, so now how I have to specify the same thing? If I have to the same thing, the particular, I have to specify as another key to the particular server. What I have to do? How I can specify? Can anybody tell? Again, if it decodes, again if it decrypts, again the same text. For example, cyber is the particular thing. It is decrypting. Again, the same text it has to get. Then what we will be doing? See, now we will be, if you consider this see, it can always go forward only, right? So these are all the alphabets we will have. How many alphabets will be having? 26, correct? So these 26, right? So if it moves forward, if any character, okay, for example, Q is there, if it has to come to this particular position again, okay, once after moving forward, again, if it has to come to this particular position, 22 characters, okay. So because of the reason, I have made my encryption key as 4, okay. So I will be moving, okay, I will be making the text in gibberish format in such a way that 4 characters, a character which is available, after 4 characters, whatever the actual character will be coming, I'll be putting that character as the original character. So that means 4 characters I'm shifting forward. So that's why if I want to get the original character, what I have to do? 22 characters I have to move forward. Okay, 22 characters I have to move forward. That's why what we'll be doing, we can always provide the key, this encryption key as 22 to the particular server. 22. See here, for example, this is the 4 is the particular encryption key we are using. So this is the particular text will be converted like this, GCF5e. So now if I am sending this particular key, okay, encryption key 22 as a public key, so what does it do? So G is there, G. From here onwards, 22 characters. Okay, just move forward. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 22 is the C character. C. Here 22 it will be putting. Okay. And again, Y is there. Y. Sorry. C is there. Okay. C is there. So from C, okay. So if you move forward, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, correct only. Yeah, I'm getting confused. Actually, sorry. So I'm thinking something is running in my mind. Okay, so that's why if these people call and ask something, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22, what we have got actually? Yeah, why we have got? Yeah, so correct. So why we have got? So why we will be putting over here. So similarly, from F onwards, so 22 characters. Likewise, if you go again, you will be having B. Okay, likewise I, you will be getting E. Likewise V will be getting R. So unidirectional only, right? You will be putting this one. Okay, so you can always leave like this, or else what you can do to make it more complicated. Okay, so you need that's what we have discussed, right? So this is the technique that we can always use, but customized also, custom technique also you can always use. For example, say whatever the encryption key is there, encryption key, uh, for example, say the position of the character, position of character square plus 2. This is my actual encryption key. Okay, so encryption key plus position of the character square plus 2. That means this means what? This is the particular logic for suppose. Okay, so that means what? I'll be specifying my encryption. Okay, if I encrypt the data, what happens? So whatever the particular 22, okay, I'll be having from C, okay, from C to 22 if I say, okay, so I'll be having what? Y, right? From C I'll be having G. Okay. G, I'll be getting G. So G, what is the position of the character over here? 1. This is the first position of the character. Okay. 1 square is what? 1. 1 plus 3 is what? 3. 1 plus 2 is 3. Okay. And again, from Y, if I calculate this 22nd position, it will be C. So C, what is the position? Second position. And 2 square plus 2. That means what? 6. And again, from B onwards, if I move to 22 positions, okay, what I'll be getting? I'll be getting uh, F. Okay, so F is the particular thing. Okay, so and again F if I put over here. Okay, and this is the third position. 3 square 9 plus 2 11. And similarly I'll be getting I, and I fourth position. This is 16 plus 2 18, and V fifth position 25 plus 27. So this is the particular encryption key. See, this is the encrypted text basically. This is the encrypted text. Okay, now this is the encrypted text. So now, so this is the actual encryption text. Okay, so I have to, what I have to specify, what I have to give the encryption key, whatever the encryption key is there, minus these two things, character square minus 2. Okay, once that means what? Wherever the particular characters you will be getting, so you have to remove the numeric things. Then actual thing you will be getting. Okay, so likewise I can always send. Okay, likewise I can always send. I can send it this kind of logic to the particular as a public key I can always maintain. That's what I mean. As a public key I can always maintain, or else as a private key also I can always maintain. If you think that this is a kind of a strong encryption, you can maintain as a private key, so that this particular encryption technique, whatever you are using, this complicated technique, whatever you are using, it won't be knowing even to the particular receiver as well, even to the particular server as well, it won't be knowing. Okay, so that is the particular stuff. Or else if you send this one, okay, even the whatever the simple encryption technique do you have, you will be always be having, and this particular thing you will not be knowing, only you will be knowing, but anybody, even the server also will not be knowing. Okay, that is the particular thing. That means what? Here we are, the basic thing is that here we are providing two keys. The encryption technique we are using as two encryption techniques. That means whatever the actual encryption techniques that you are using is there, right? So you are not revealing it to anybody, even to the server as well. Wherever you are requesting or wherever you are sending the data to the particular server, okay, so you are not even revealing to that particular thing, but you are maintaining this particular information for yourself itself. Okay, so it is very confidential that you yourself know that particular thing. Whereas for all the other people, you are sending it as a public key. The public key is different and the private key is different. And in asymmetric encryption, data cannot be reverted back. It is only unidirectional. Okay. And when it comes to security, this is more secured. Okay. So this is a good interview question. Which is more secured, symmetric encryption or asymmetric encryption? Asymmetric encryption is always secured. Okay. So that is the particular stuff. See, now let us see it practically as well. Let us show me practically. So whatever we have discussed right now. So let me go over here. Meter attack. Meter attack is one of the prominent thing that we'll be discussing as well. Okay, so yeah, this is the only one. Okay, so encrypt and decrypt text online. So I can always send you these links as well so that you can also check. Okay, so now yeah. How can I close this one? It is not getting closed. Arre yaar. So see over here. Arre, he has not given in 2 mark as well. Arre yaar. What is this? Definitely I have to view this or what? If I open this kind of third-party websites, that's why. Okay, watch our ads. We have to definitely watch the ads because I have already used it so many times. Okay. Sorry, yaar. Okay, let it be. Okay. So reward in 12 seconds. We have to wait for 12 seconds. Let me close this one and play. After 12 seconds, we can open this one maybe. So if I open another one, let us find our luck whether we can open this or not. RSA encryption. So this is the one what I want to show is for symmetric encryption. The thing that I am showcasing right now is for symmetric encryption. Similarly, we can always check asymmetric encryption as well. Okay, so by this one. So and again I have forgot to tell you. So this kind of symmetric encryption is called as AES encryption as well. What is that? AES algorithm. The symmetric encryption will works on AES algorithm. This is important again. AES algorithm. Okay, whereas asymmetric encryption will be working as what is that? RSA algorithm. RSA algorithm. Okay, so RSA algorithm. So AES algorithm stands for Advanced Encryption Standard. We need not know the abbreviations and all. So AES algorithm, if you can know the particular thing, even though this is not being asked, okay, in interest and all. So advanced encryption standard, it is called as, and it is something is there, RSA, Revert Shamir Andelman algorithm, something is there. Okay, so we need not know about the full forms and all. So this will be using AES algorithm. This will be using RSA algorithm. Okay, that's what we want to know. Okay, that's it. Okay, and again, if I open this one, let us try our luck again. Just stopped over here. Reward in 7 seconds. Yeah, it is not opening. Okay, so see, this is the asymmetric encryption. It's a reversed Shamir Aldenman. Okay, so this is the particular encryption technique we'll be using. So what it is doing over here? So we can always generate a particular RSA key pair. Okay, if I generate this one, it will be saved as a private key and a public key. See, public key and private key. Two keys it will be saving. Okay, so public key is for the servers for the external world, and private key is for the same client. Okay, so that is the particular for the same computer. So now he is asking over here to enter a plain text to encrypt. So if I give the same thing, whatever we have given, okay, or else cyber security. cyber security if I give over here. Okay. So with this particular, whether you want to use public key or private key, it is asking, we can always use the public key. And if I say encrypt, so now it has been encrypted. So by the particular algorithm, whatever the AES RSA type of algorithm is using, it is encrypted like this. So now what I'll be doing, this is the encrypted text. So I'll be copying the entire text, encrypted text, and I'll be coming over here. So I'll be pasting over here in order to decrypt again. So whenever I decrypt by using the private key, see, now I'll be decrypting by using the private key over here. Okay, so it has been highlighted, right? Private key only. So now if I click on decrypt, again, the same text should be coming. Which same text? Cyber security. Okay. So if I click over here, see, I'll be getting the same text. So what has happened over here? Whenever it is asking for a RSA key to be generated, whenever I click on that one, two keys have been formed. That means the encryption technique has been divided into two. One is the public key and other is the private key. So once if you give the particular text, whatever the text you want to encrypt, okay. So public key, it will be this text will be encrypted over here. Okay, and then again, if you want to decrypt this one, you can always use, and you can always decrypt this particular thing as well, so that it will be coming to the original text. Okay, that is what you can always do for the asymmetric encryption. So symmetric encryption, we cannot. I am not able to show you at this particular moment because it is not making me to open actually. If I say something, if I encrypt, it is not making me to open as well. So that is what. Okay, so simple encryption, it will be happening. No keys will be there. See, if I say encrypt, it will be encrypting this one. And if I put the encrypted text over here, again, if I say decrypt over here, it will be decrypted as well. Okay, that is what it will be doing, right? So this is called as the symmetric and asymmetric encryptions. We can always do. Okay, we can always use the particular logics as a symmetric and asymmetric encryptions, right? So that is the particular stuff. And if you see the differences, right, between the symmetric encryption and asymmetric encryption. So now you tell me what are the differences, what you have understood. Can you tell? Symmetric encryption and asymmetric encryption. In start something what you have understood. Symmetric. Okay, so this is asymmetric. So it works on AES algorithm, RSA algorithm. So if you see the first difference, so which is faster? Which is faster in your opinion, symmetric encryption or asymmetric encryption? Which is faster? Which one is faster?
Symmetric.
Yeah, symmetric encryption is always faster. Why? Because symmetric encryption is faster. Because it uses less keys in general. In general, there is no rule that it has used less keys only. As we have discussed, I have removed it, right? So I have told you, right? Even whenever you are using, okay. So even in asymmetric encryption also, whatever the public key is there, you can make the public key simple and you can make the private key complicated. Okay, or else you can make the private key simple and public key complicated. But in general, the private key will be in symmetric encryption. It will be simple. It will be having less keys. So why it will have less keys? Basically, it can revert back the exact position. If I say what we have done, example we have seen. If I say I will be moving 4 positions forward, so then what the server has to do? It is bidirectional, right? It will be going 4 positions backward. That's it. It will be going 4 positions backward. If I say 4 positions forward, I'll be going. It will be going 4 positions backward, and it will decrypt, and it will be decrypting. That means what? Simple keys. What are the 4 keys I have used? It has to go back to the 4 keys. That's why it is very fast. Okay. So symmetric encryption is faster because of its usage of smaller keys.
Single key. Yeah.
Single key pair is for security. So even if you single key pair is for security, yeah, that is also correct. Okay. So but again, even if you in single key pair and the two simply because it is bidirectional. Most importantly, it is bidirectional. So whatever the
Yeah.
thing specify over here, it again come back only to the particular thing. Okay, so that is the thing. Okay, so even though, for example, there is no concept of we do have the concept of dual keys for the asymmetric encryption. So asymmetric encryption, again, it is unidirectional only. Even though there is no concept of two keys, then what it has to do, it has to move forward. Okay, and then only it has to come to the position. And that means what? All the 22 characters, as we are seeing in the example, right? All the 22 characters it has to read, right? Here it is going only 4 positions backward. So in that way, it is fast. Okay, so it uses smaller keys. So which results to and again lower CPU cost as well, right? It achieves lower CPU cost as well. Okay, that is also important. Whereas this one it is slower when compared to symmetric encryption. Okay? So because of the larger keys, right? That is the particular stuff. And again, the text whatever the text that we'll be using, right? The Caesar cipher technique that we have used, it is of the same size as in the plain text. Yeah. So here also, actually this point is included over here only. Okay. Anyhow, so the cipher text. Okay, the cipher text whatever we have made. Okay. So it is same as the plain text. And again, it is not the same. Okay, so it may be, again, if you change the logic, we have seen, right? If we can implement our own logic in general, the ciphertext is same as the plain text. Okay, but here definitely it will be changed because another logic we have to implement, right? Only not if you implement a logic, another logic apart from the logic whatever you have implemented earlier, apart from that you have to implement another logic as well. That's why the ciphertext here will not be is not same as the plain text. Sorry for my writing. Okay, so there is a particular stuff. Okay, and what else we can specify? The most important thing, which is less secured, symmetric, as we have discussed already. Okay, symmetric encryption is always less secured because only one key, and that key you have to specify to the server. Whereas this one, it is more secured. Is more secured because it will be having two keys. Okay, so this is what we can always specify, right? So this is the
And
encryption
still,
techniques that we can
yeah.
always use.